we're going to go over the definition of a logarithm. Okay. So let's say for all positive numbers, and that'll be represented by the letter B, where we know that B doesn't equal 1 and some value of x is positive. Then log of base B of x equals y is equivalent to b to the power of y equals x. Okay. Or you can just rewrite it as log base b of x equals y is the same as b to the power of y equals x. Okay. Where b is the base. And y is the exponent. Okay. Some of you might remember this from math, the 1000. If so, this will probably be a review. Alright, so let's say, for example, let's say if we wanted to convert from a logarithmic equation to an exponential equation. Okay, so we're just going to go ahead and kind of make a graph here. So we have our logarithmic equation, which is log base b of x equals y. We have our exponential equation, which is b to the power of y equals x. Okay, so let's say for A, we have log base 2 of 8 equals 3. Let's say for B, we have log base 3 of 81 equals 4. Say for C, we have log base 4 of 4 equals 1. Now let's say for D, we have log base 5 of 1 over 125 equals negative 3. Okay, so if we converted these are our solutions here. We have b, which is your base, to the power of y equals x. So this would be 2 to the power of 3 equals 8. Okay. So for b, your base to the power of y equals x. So 3 to the power of 4 equals 81. Okay. And for C, I wrote C without parentheses because sometimes you'll see parentheses, sometimes you won't. So I don't want you to think that if you saw one without parentheses, then something's wrong. They just kind of vary. Okay. So 4 to the power of 1 equals 4. And for D, 5 to the power of negative 3 is 1 over 125. Okay? Which are all true. We're just converting it from one to the other. Okay, so let's see if you can do the next three. Let's say E, F, G. I probably should give that more room. Okay, so let's say log base 4 of 64 equals 3. Say log base 7 of square root of 7 equals 1/2. And let's say log base 6 of 1 over 36 equals negative 2. Okay, just go ahead and convert those all to exponential equations. Alright, so for this one, your base to the power of y equals x, so 4 to the power of 3 equals 64. Okay, for f, 7 to the 1/2 power equals square root of 7. Uh-oh. Clean that up a little. And for g, 6 to the power of negative 2 equals 1 over 36. Okay, which are all true. Okay, those are the definition of your log functions. Okay, so now we're just going to convert it from one to the other, from exponential to logarithmic, which is really the same thing. All right. Okay, still writing. All right. Okay, so here we're going to convert from exponential to logarithmic. Okay, so in other words, we're going to convert it from b to the power of y equals x to log base b, straighten up that g a little bit, log base b of x equals y. Okay, so this is our exponential function. And this is our logarithmic function. Okay, so let's say for this one, for a, 8 to the power of 0 equals 1. Say for b, 6 to the power of 1/3 equals cube root of 6. And let's say for c, 1/4 squared equals 1/16. Okay. So you have b to the power of y equals x. So here, you have log of base b, which is 8. Your x is equal to 1. And your y is equal to 0. So 8 to the power of 0 equals 1. Okay. So for b, your base is equal to 6. Okay. Your x is equal to cube root of 6. And your y is equal to 1/3. Oh, equal. Okay. And for this one, your base is equal to 1/4. Your x is equal to 1/16. And your y is equal to 2. Okay, so let's see if you can try this one on your own. And convert that one to a log function. All right. So for this one, your base is equal to 6. Your x is equal to 1/36. And your, oh, that makes that one up. Yep, and your y is equal to -2. Here we go. Right. Any questions on either one of those? All right. Oop, anyone's still writing? All right. Okay, so let's say, for example, here, we wanted to solve each of these for x. Okay, so let's say for a, log base x of 25 equals 2. Say for b, log base 3 of x equals -3. And say for c, log of base 1/2 of 1/16 equals x. Okay. So for each one of these, you're going to convert from log of base b of x equals y to your base to the power of y equals x. Okay, so you know for a, log of base b of 25, oh, base a. Well, you can change it to b if you like, but I will just change it to x. Equals 2. Okay, so we know this is your base squared equals x, which is 25. Okay, so if we square root both sides, we know x is equal to plus or minus 5. Okay. But remember, one of the stipulations for the base is it has to be greater than 0. Okay, so the base is greater than 0, so that means x equals 5 is your only solution there. Okay, now for B, draw a little separation there. Log base 3 of x equals negative 3. Just 3 to the power of negative 3 equals x. Okay. Or you can write it as, since it's a negative exponent, 1 over 3 to the third equals x. Which 3 times 3 times 3 is 27. So you just make it x equals 1 over 27. I was really struggling to not flip it around because my own little personal obsession with having the variables on the left. Okay, now for C, we do the same thing. Log of base 1/2 of 1/16 equal x. So we're going to convert that. 1/2 to the power of x equals 1/16. Okay, so for this one, we know that 1/2 times 1/2 times 1/2 times 1/2 would equal 1/16. So that means, in this case, x would have to equal 4. Excuse me. All right. Any questions on that one? Excuse me. All right. Let's see, I'm still writing. Okay. Okay, so let's say if we wanted to evaluate the expressions. Okay, so let's say for A, log base 8 of 64. Okay, now let's say for B, log base 3 of 1/3. And let's say for C, log base 4 of 2. And let's throw a little odd one in there, and let's say for D, log base 5 of 0.04. So with those, the first thing you want to do is rewrite them. And just rewrite it as log base 8 of 64 equals y. Okay, so now that you have that equals y, you just rewrite it as 8 to the power of y equals 64. Okay, so since we know that 8 times 8 equals 64, we know that y would have to be 2. So since y is equal to log base 8 of 64, we have our answer. Any questions on that one? All right. Okay, so let's say for problem B, first thing we're going to do is rewrite it. as log base 3 of 1/3 equals y. Okay, so that would give us, kind of separate that a little bit, 3 to the power of y equals 1/3. Okay, so for this one, we know that 3 to the negative 1 equals 1/3. So we know that y would have to equal negative 1. Okay. So for C, first thing we want to do is rewrite it. Okay, so that's log of base 4 of 2 equals y. Okay, so that would give us 4 to the power of y equals 2. Okay, so here we can see that, let's say 2 squared equals 4. Okay, so since we know 2 squared is equal to 4, let me give a little bit of room here. We can actually change that to be 2 squared to the power of y equals 2. Okay. Which, just by our exponent rules, 2 to the power of 2y equals 2 to the first power. 2 is just 2 to the first power. Actually, that gives us this one. I should have wrote that over here, but erase this arrow, because that should have been over here. Okay, so the only way this could be true is if 2y is equal to 1. Okay, does that make sense? All right, so sometimes you have to kind of play around with them a little bit. Okay. So if 2y is equal to 1, it meant y is equal to 1/2. So pretty much the square root of 4 is equal to 2. All right. Any questions on that third one? All right. Okay, and for D, you won't see one like D on the test, but I think they have some like it on the homework, so I just wanted to make sure it was covered. Okay, so we know that 0.04 is actually equal to 1/25. Okay, so we have log of base 5 of 1/25 equals y. Okay, so if you do end up with one like that, just convert the decimal to a fraction and then just do the same steps. Okay, so we have 5 to the power of y equals 1/25. Okay, so we know that 5 to the negative 2 equals 1/5 squared, which is 1/25. Uh-oh. Okay, so we know that y would have to equal negative 2. All right, any questions on that one? Okay. Still writing. So for all of these, the base was actually given. You're going to stop in a couple minutes. You start it. The base is usually given, but there are some times where the base is not given. And when it's not given, you pretty much assume it's a 10. So it's kind of like if you have the square root of 4, you just automatically assume it's a 2 there. Same where you have cube root or fourth root or fifth root. You just assume it's a 2 when it's nothing there. Oh, clean that up some. So same thing with logarithm. When there is no base given, assume that the base is equal to 10. Okay. This is called a common logarithm. Okay. So in other words, if you have log of x, that's just log base 10 of x. All right, might as well